In this video, we are going to learn about inertia. Now, what is inertia? Inertia is an inherent tendency or property of a body meaning, of course, anything that has mass, because of this thing called inertia, what happens is, if a body is at rest, then this body forever wants to continue in the same state of rest. Or if a body is in motion, then the body forever wants to continue in the same state of motion. Until, of course, a force acts which makes the body act in a different way, or which, so to say, changes the state of the body. So if this body is at rest, this pen is at rest, the pen wants to forever continue in the same state of rest because of inertia. Until, of course, a force acts because of which the state of rest changes. And likewise, if a body is in motion, because of inertia, because of this property, this inherent tendency of a body called inertia, the body would forever want to continue in the same state of motion. So this inherent tendency or property, because of which a body at rest wants to continue in the same state of rest, or a body in motion wants to continue in the same state of motion, is what is called your inertia. Now, for example, if we are in a moving car, a car is running at a certain speed and the driver suddenly applies the brake. So what happens is, the passengers in the car will lean forward. You must have experienced this. Okay, you're inside a car, the car is running at a certain speed, suddenly the brake is applied. Okay, what happens is, the passengers, we happen to lean in the forward direction. Now, why is that? Because our body, when the car was moving, our body was in motion along with the car. Our body was running at the same speed of the car. So our body was in motion. Now, when the brakes are suddenly applied, since our body was already in motion, our body wants to continue in the same state of motion. The body wants to continue in the same state of motion, because of which what happens is, the body leans forward, remember. And that happens because of, therefore, inertia. Likewise, if a body is at rest, suddenly the car starts. This also you must have experienced. If you are in a car at rest, suddenly the car starts, what happens is, our body leans backward. Why? Because our body was at rest initially, so our body wants to continue in the same state of rest because of inertia. Okay, so therefore our body leans backward, remember. Likewise, we have a carpet, okay, and we beat the carpet with a stick. What happens is, dust particles will fall off. Why? Because the dust particles initially, when we have the hanging carpet, the dust particles are at rest along with the carpet. Now, when we beat the carpet with a stick, the carpet moves backward because of the force that we are applying. Now, the carpet moves backward, but the dust particles which were initially at rest, they want to continue in the same state of rest. Therefore, the dust particles will stay there, but the dust particles will remain there, but the carpet moves backward, and thereby the dust particles, they fall off. That also, therefore, is because of inertia. There are other examples also, that of inertia. Now, like I've already mentioned before, inertia depends on the mass of the body, remember. More the mass of the body, more will be the inertia, and lesser the mass of the body, lesser will be the inertia, remember. Okay, so if I have a ball, a small ball at rest, and a bigger ball at rest, bigger iron ball. My pen is also not writing. So I have a bigger iron ball and a smaller iron ball. Both are at rest. Now it will be difficult for me to push this iron ball, to make this bigger iron ball move. Why? Because this bigger iron ball has more mass, and thereby more inertia, remember. So bigger the mass, more is the inertia. Lesser the mass, lesser will be the inertia. Now, inertia can be of two kinds. One is called inertia of rest. And the other is called inertia of motion. So one is inertia of rest and inertia of motion. Now, what is inertia of rest? Inertia of rest is that kind of inertia because of which what happens is, if a body is at rest, it wants to continue in the same state of rest. What is inertia of motion? Inertia of motion is that inherent tendency because of which, if a body is in motion, it wants to continue in the same state of motion. So inertia of rest applies to bodies at rest. and inertia of motion applies to bodies in motion. So if a body is at rest, it wants to continue in the same state of rest. Okay, so that inherent tendency is your inertia of rest. The inherent tendency because of which a body which is in motion wants to continue in the same state of motion is called inertia of motion. So what are the examples of inertia of rest? If a car is at rest, it suddenly starts. Our body, which was initially at rest, wants to continue in the same state of rest. Therefore, it leans backward. That is an example of inertia of rest. Hanging carpet example that we discussed before, and dust particles falling off, that is an example of inertia of rest. Likewise, inertia of motion. Our body, we are in a moving car, and the driver suddenly applies brake. Our body, it moves forward. Why? Because our body was in motion. It wants to continue in the same state of motion. So this happens. The passenger moves forward because of inertia of motion, so to say. Also, another example, when a passenger jumps out of a moving train, a train is moving and someone jumps out of the moving train, what happens is the person will fall down. Why? Because when the person is inside the moving train, his body is in motion. Now, when he jumps out and lands on the floor, lands on the ground, his body suddenly comes to a stop, abruptly comes to a stop when we jump out, on the ground. But our body was earlier in motion, wants to continue in the same state of motion, and thereby what happens is the person falls down because his feet has abruptly come to a stop, but his upper part of the body wants to continue in the same state of motion. Since he was already moving, initially was in motion, therefore the person will fall down. His feet has come to a stop, but upper body wants to continue in the same state of motion, therefore he falls down. So this also happens because of inertia of motion. So this is about inertia. Now let us talk about something very, very important, which is Newton's first law of motion. Now the statement for Newton's first law of motion goes like this. When a body is at rest, it continues to be at rest. If this pen is at rest, it continues to be at rest. And when a body is in motion, uniform motion meaning uniform velocity, remember, that means same speed and same direction. So if a body is in uniform motion, it continues to do so, meaning it continues to be in uniform motion unless some external force acts to make it behave in a different way, to make it act in a different way. So if this body is at rest, it continues to be at rest unless an external force acts to make it move. Also, if a body is in uniform motion, meaning if a body is moving at the same speed, constant speed, and in the same direction, of course, that is uniform velocity. Uniform motion means uniform velocity, remember. This body will continue to do so forever, will continue to move in uniform motion unless an external force acts. So if the body is moving, I apply a force in the opposite direction, the body will come to a rest. So the state of motion of the body has changed to that of state of rest. So that is because of external force acting, which makes it behave in a different way. All right. So this is the statement for Newton's laws of motion. So basically you can see Newton's laws of motion talks about two things. One, it talks about a body at rest. So if a body is at rest, it continues to forever be at rest unless an external force acts, which changes the state of rest. The next thing it talks about is about a body executing uniform motion, in uniform motion, so to say. Uniform motion means it is not talking about acceleration, remember. Uniform motion means there is no change in velocity, there is no change in speed whatsoever. There is no change in direction. The body is moving in a specific direction, one direction. So Newton's laws of motion is talking about that uniform velocity, remember. So it talks about a body at rest, it talks about a body in uniform motion. So a body is in uniform motion means, remember, the body is not accelerating. The body is not accelerating means there is no force acting on the body. So a body could be moving, but still there could be no force acting on the body. This is an ideal case actually. Uniform motion is an ideal case. Alright. So if there was no force of friction, if I push this pen, this pen comes to a stop. Why? Because force of friction is acting on it, makes it stop. Force of friction makes the body stop. But if there was no friction, force of friction, by giving it a slight push, this pen would actually go on moving forever without stopping. But it would move in the same direction and with the same speed. That is a case of uniform motion, remember. So if there was no dissipative forces like friction, by giving this pen a slight push, it would go on moving forever. By itself, then it would move. Forever it would move without we pushing it, without we applying an external force, so to say. So that is the case Newton's first law of motion is talking about. So if a body is in uniform motion, it continues to be in uniform motion. It continues to move forever. Unless an external force acting makes it act in a different way. Or, an external force acting changes the state of the body. So say this body is moving with uniform motion, uniform velocity. I apply a force, the direction of the body changes. Or I apply an opposing force, the body comes to a stop. So that is what Newton's first law of motion is talking about, remember. So get one thing very, very clearly. So if a body is at rest, you have to understand there is no force acting on this body. Okay? And if a body, or rather let me say, if a body is at rest, there is no net force acting on the body. No net force acting, meaning there is force of gravity acting on this pen right now. Alright, but there is normal reaction also acting on it. Normal reaction and force of gravity are equal and opposite to each other. Okay, so therefore the net force acting on the body is 0. Likewise, I'm applying two forces using my two fingers. I'm applying two forces on the pen, but these two forces are equal and opposite. Okay, so the net force acting on the body is 0. So if we see that a body is at rest, the net force, the total force acting on the body is 0. So to say, there is no force acting on the body that we need to understand. Also, if we see a body in uniform motion, which doesn't happen in reality, this is an ideal case. Like I said, if there is no force of friction, I give it a slight push, it goes on moving forever. So if we see a body in uniform motion, then also we have to understand there is no net force acting on the body. There is no force acting on the body whatsoever. Okay? So this is what Newton's first law of motion talks about. Finally, in this video itself, let us also talk about Newton's law of gravitation. Just the statement for Newton's law of gravitation. Newton's law of gravitation talks about the force of attraction between two masses, any two masses, like the earth and this pen. This pen is being pulled by the earth. So there is a force of gravitation acting between two masses, the earth, say for example, and the pen. Now say M1 and M2 are the masses. Okay, M1 say is the mass of the earth, M2 is the mass of the pen, and they are separated by a distance r. And one more thing I would like to tell you, the force of gravitation is always attractive in nature, remember. Unlike your magnetic force, okay, unlike electrostatic forces, where like charges repel each other, unlike charges they attract. Likewise, in magnetic force, unlike poles, North Pole and South Pole, they attract each other. But like poles, North Pole and South Pole, they repel each other. So magnetic forces, electrostatic forces can be both attractive and repulsive. But gravitational force is always attractive, remember. The pen is always attracted by the earth, never repelled by the earth. So gravitational force is always attractive, remember. Now what is the statement for Newton's law of gravitation? It says, the force of attraction between any two masses, M1 and M2, if the separation between them is r, so the force of attraction between them is directly proportional to the product of the masses. So whatever is the product of the masses, M1 and M2, so force is directly proportional to that. And it also says that the force of attraction between these two masses is inversely proportional to the square of the distance between them. That is, greater the separation between the two masses, lesser is the force of gravitation, of course. So combining these two relations, we get F is proportional to M1, M2 by r squared. Now a proportionality sign can always be replaced by an equal to sign. So F is equal to capital G M1 M2 by r squared. Proportionality sign can always be replaced by an equal to sign provided we add a constant, and the constant is capital G over here. Capital G is what is called your universal gravitational constant. So this is the equation that we get from Newton's law of gravitation. So you should remember the statement for Newton's law of gravitation. And please do not forget Newton's law of gravity. The gravitational force is always attractive in nature, unlike a magnetic and electrostatic forces.